There's this hidden bottleneck deep inside so many of our software systems, and it's slowing things down in ways we might not even notice. It all comes down to how our different services talk to each other. And today, we're going to look at a way to fix it. Let's dive in. Okay, so let me just ask you this straight up. Have you ever been working on a system and just felt like the communication between your own microservices feels kind of sluggish? Like you've got all this incredible computing power, but there's a traffic jam somewhere. Well, that is the exact question we are going to unpack today. So on one side, you've got the usual suspect, REST. We all know it, it's reliable, it uses those familiar JSON payloads over HTTP/1.1. It's fantastic for public-facing APIs, but internally, it can cause some serious traffic jams. And then, on the other side, we've got the challenger, gRPC. It's built from the ground up for pure speed, using something called Protobufs and running on the much newer HTTP/2. Right, so before we jump into the shiny new solution, we really need to understand the problem. So let's take a closer look at this microservice traffic jam and figure out why the tools we love for the public web aren't always the best fit for our internal systems. This right here is the heart of the issue. It's not just one thing that makes REST slow internally, it's a whole bunch of things that add up. You've got the slow text-based parsing of JSON, the fact that it doesn't really do streaming out of the box, and then there's weak typing, which means you only find out something's wrong when it breaks at runtime. Now, on their own, these are maybe just small annoyances, but when your services are chattering back and forth thousands of times a second, they compound into a massive performance bottleneck.
But what if there was a different way? I mean, a framework designed specifically for this kind of high-speed, high-frequency internal chatter. Well, this is where our hero, gRPC, enters the scene.
At its core, gRPC stands for Remote Procedure Call. And this definition, it perfectly illustrates the magic of it. It lets a developer on one computer call a function that's running on a completely different computer, as if it were right there on their own machine. It's amazing. All the messy networking stuff, the serialization, the TCP connections, the parsing, it all just disappears from view. It's kind of like magic for developers.
And the developer experience, it's just as clean. It's this beautiful, structured four-step process. First, you define a strict contract, a single source of truth, in what's called a proto file. Then, you automatically generate all the boilerplate code for both your client and your server. From there, you just fill in the server logic, and then you call it from the client like it was any other local function. This whole contract-first approach gets rid of so much guesswork. It makes development not just clean and predictable, but really, really efficient.
Okay, so we've established that it's fast, but why is it so much faster? What are the secret weapons that gRPC has under the hood that make all the difference? Well, it really comes down to two key pieces of technology. Secret number one is protocol buffers, or Protobuf for short. Just look at this comparison. Where JSON is text-based and can be pretty large, Protobuf is a super compact binary format. Here's a good way to think about it. JSON is like a long, handwritten letter that the computer has to carefully read word for word. Protobuf is like a tiny, dense barcode. The computer doesn't need to read anything, it just scans the barcode instantly. And that makes parsing wicked fast.
The second secret weapon is that gRPC is built on top of HTTP/2. Now, if HTTP/1.1, which is what REST typically uses, is like a single-lane country road where every car has to wait for the one in front of it, then HTTP/2 is a massive multi-lane superhighway. It uses a killer feature called multiplexing, which lets tons of requests and responses happen all at the same time over a single connection, no more waiting in line. On top of that, it compresses headers, and as we'll see, it was built for streaming.
And that brings us to what might be gRPC's most powerful and unique feature, the thing that really truly sets it apart from traditional APIs. Let's talk about its streaming superpowers. First off, you have Unary RPC. This is the classic model we're all familiar with. The client sends one request, the server does its thing, and sends back one response. Simple, effective, gets the job done for a lot of cases. But then we have server streaming. This is where the client sends one single request, but the server can send back a whole stream of responses over time. So think about getting live notifications from a server. Instead of you having to constantly ask, hey, anything new yet? How about now? The server just pushes updates to you as they happen. And you guessed it, we can flip that around with client streaming. In this case, the client sends a stream of messages to the server. This is perfect for something like uploading a huge file in chunks or sending a constant stream of data from an IoT sensor. Once the client says, okay, I'm done, the server sends back a single confirmation. But this is the real game changer. Bidirectional streaming. With this, both the client and the server open up a single long-lived connection, and they can just send messages back and forth independently whenever they want. It's a true two-way conversation. And this is the critical difference. This kind of sustained, real-time dialogue is something REST simply was not built to do. And this isn't just some abstract, theoretical concept. This superpower enables the real-time apps we use every single day. Think about it. A chat application? That's bidirectional streaming. The real-time movements of players in a multiplayer game? That's it too. A live stock trading dashboard or multiple people editing a Google Doc at the same time? All perfect examples of the superpower in action. So gRPC is obviously incredibly powerful. You might be thinking, I should use this for everything. But hold on, that doesn't mean it's the right tool for every single job. The final piece of the puzzle here is knowing when to use it and, just as importantly, when not to. You should absolutely reach for gRPC for your internal, high-performance microservices. I mean, it's what giants like Netflix and Uber use to manage their ridiculously complex backends. It's perfect for any real-time system that needs streaming. And because that .proto contract works with any language, it's fantastic for polyglot systems, where your Java team needs to talk to your Go team. And of course, its tiny payloads make it great for IoT devices and mobile apps. However, and this is just as important, you should probably stick with REST for your public-facing APIs. Why? Because browser support for gRPC is still pretty tricky. Also, if you need to easily debug or inspect API calls and want a human-readable format, JSON is definitely your friend. And of course, if you're stuck working with older legacy systems that can't handle HTTP/2, well, gRPC is a non-starter. Okay, so let's put it all together. This final chart is the ultimate cheat sheet. On the one hand, gRPC gives you the HTTP/2 superhighway, tiny Protobuf payloads, incredible speed, built-in streaming, and strong type safety, but it struggles with browsers. On the other hand, REST gives you universal browser compatibility and easy-to-read JSON, but it's slower, has no native streaming, and is weakly typed. Different tools for different jobs.
If you take only one thing away from all this, let it be this right here. This is the rule of thumb. Use gRPC for the high-speed superhighways inside your system, and use REST for the public roads that connect your system to the outside world.
And that brings us to our final thought. Now that you know the difference, I want you to take a hard look at your own architecture. Is it possible that the trusted, familiar tool of REST has become the invisible bottleneck that's been slowing you down all along? Something to think about. Thanks so much for joining us.